Welcome students. The remaining topic what has left in the module 4 today I am going to complete all the things. Let us continue that. First, I am explaining the ideal op-amp. This one I already explained in the first video itself. But for differential, I want to explain the differential amplifier. For that topic, I need this. We all know that the op-amp consists of a two terminal. One is a non-inverting terminal, and there is a inverting terminal, and we'll get the output of that. So output, how I am getting means the difference between these two input with a gain of that. If I'm not giving any feedback means it will act as an open loop circuit. Before moving to a differential amplifier, so we have a two terminals. For practical manner we have to see. So I am giving in this slide the loop, closed loop for this, and if closed loop for this, and we have verifying the output of this one. You can see here I have taken the two figures. So why I am taken like this means I am giving the input to a inverting terminal in the first figure, and non-inverting terminal I am grounded. In the second figure I am giving the input to a non-inverting terminal, and inverting terminal I have grounded. If I take like this, the first figure yields the output as V01 is equal to minus R2 by R1 into V1 because of the virtual concept I explained in the second video, I think. In this, the second one, it gives the output as V02 is equal to 1 plus R2 by R1 into V2. Why? Because means we are giving the input to a non-inverting terminal. So next I will explain you the differential amplifier, how it's going to work. In differential amplifier I am giving the input for both inverting and non-inverting terminal. So how I take the output means V out should be equal to V01 plus V02. So V01 we know that. So V01 is the output will obtain when the input is given to a inverting terminal. So we all know that is I have written here, that is what, minus R2 by R1 into V1. So next is output is what, V02. V02 how I am taking V02 I have given to a non-inverting terminal, so I can write the output as 1 plus R2 by R1 into V2. I explained you how I have obtained this R2 and this 1 plus R2 by R1. So what I want to get? I want to get the difference difference between the input in the output side. So I want to eliminate this 1 plus R2 by R1. So what I am going to do? 1 plus R2 by R1 should eliminate with R2 by R1. So in the next slide I will explain you how we are going to do that. So how I am eliminating means, so I am just taking the two resistor which has connected parallelly for a non-inverting terminal and then I am giving the input for that. So V2 passes through R1 and R2 I have grounded. So if I take using the voltage divider rule, I will consider one junction here. So I will name that as a V plus, and this V plus is given as what? According to voltage divider rule, I can write this as R2 divided by R1 plus R2 into V2. So I will put this V plus in the above equation. In the above equation what I have written, V out is equal to 1 plus R2 by R1 into V plus. When I will get this, I will assume V1 is grounded. I am just giving the V2 output. I will get this equation. What is that? V out is equal to 1 plus R2 by R1 into V plus. I will substitute this V plus means the numerator denominator will get cancelled. The remaining is what? R2 by R1 into V2. This one I have substituted in the first equation. What is that? V out is given as minus R2 by R1 V1 plus 1 plus R2 by R1 into V2. That one I am just eliminating according to this rule. I will eliminate that. Finally I will get R2 by R1 V2 minus V1. This is a differential amplifier. Next we'll move on to integrator. How this operational amplifier can be integrate the thing here. So I have taken the two figure here. This is a basic operational amplifier figure. In this one, what I have given, the non-inverting terminal I have grounded. The inverting terminal I am giving the input. How I am giving? I am giving through a resistor R1, and one more feedback circuit I have taken, that is I have passes through the RF. So in the feedback circuit, if I eliminate this RF with a capacitor, then the operational amplifier circuit will act as a integrator. Next we'll see the operation of an integrator circuit. So I am giving the input for a inverting terminal. Okay, when I apply the voltage, the current passes through here. I can write that as a IN. And the feedback circuit, in the feedback circuit I have taken the capacitor, and the current passes through here. I am just representing that as a IC. Okay, and the junction has formed between here and here, so that junction I am called this virtual ground concept. So here the voltage, whatever the current passes through the opamp, will be as 0. So the IN means the current IN should be equal to IC. So IN, how can I write? So VN minus 0. 0 means because of an virtual ground concept, it is a 0. So next is divided by R, that should be equal to IC. Okay, this IC, how I can write means, this IC is the current through the capacitor. The current through the capacitor I can write as IC is equal to C into dVc divided by dt, and charges across the capacitor. Capacitor is nothing but what? It will charge and discharge the things here. So the charging of the capacitor is given as Q is equal to C into V. Okay, so I is given as dq by dt. Okay, because I am taking that. So finally I will get IC is equal to C dVc divided by dt. Next, so I am just substituting that one IC value. So it is given as Vin divided by R should be equal to CF into dVc divided by dt. CF into dV by dt. I am just taking that difference, the derivative of Vc. Okay, so this Vc I can write as Vc is nothing but what? Voltage across this capacitor. So this feedback one I can write, due to this virtual ground I can write that as 0 minus V out. So differentiation of an 0 is 0 itself. So I'm just taking this one. So finally I will get V in is divided by R should be equal to minus CF into dV out divided by dt. I will rewrite this. So dV out divided by dt is equal to minus 1R CF into Vn. Finally, the output I can rewrite as, so in the previous slide I have taken as derivative of V out. I want to eliminate that derivative, means I will integrate with both the things, so it will get cancelled. So I will get V out of t is equal to minus 1R RCF integral V in of t into dt. So like this we can integrate the thing. So this is a one example I have taken in this slide. So if I give the input as a DC input, so I am giving the 1 volt DC input for this op-amp, I will get the output below how I have written. So here minus 1R RC into CF I have. So I will get in the downwards, and it will linearly increase. At one particular point you will get the constant. Next we'll move on to differentiator. So don't confuse here. Differential amplifier is different from differentiator. So I have taken here this, observe in the first figure. So what I am given, I am giving the two inputs. I am getting the output as A into V1 minus V2, means difference between the input. But in the next figure, you just observe what I have given for the differentiator. I am just passing the one input. I will get the output was derivative of input. So V out is given as what? dV in divided by dt. So this is a simple example I have taken. If I give a DC input for the differentiator, I will get the output as what? Exactly 0, because it is a derivative of that. So derivative of constant is what? 0. So I will get the output as 0. Now we'll see how the differentiator is going to work. So basic figure, how it consists of any input, we can give an input and we have one resistor and feedback resistor. If I want to do this opamp, the differentiator operation means I am eliminating the resistor R1 with a C. You can see in this figure. So the non-inverting terminal I am grounding, I am giving the input to a inverting terminal through the capacitor. When I arrange the circuits like this, it will act as a differentiator. So when I apply Vn, I will get the current as a IC through and feedback. So I have taken RF, so I will give a feedback current as IF. So the IC should be equal to IF, and we all know that the virtual ground concept, this junction is going to yield 0 volts for us. So I want to take a input current. IC means the current is passes through the V input through a capacitor. So IC I can write as C into dVc by dt. That should be equal to IF. How I can write? So due to the virtual ground concept, it is 0 minus V out divided by RT. C into dV in divided by dt should be equal to minus V out by RF. So if I rearrange this one, I can rewrite that as a V out should be equal to minus RF into C into dV in by dt. So this IC is a derivative of C into dV by dt. Finally, I will obtain the output of the differentiator is V out should be equal to minus RFC into dV in by dt. This is about the differentiator. Thank you, student. So your model 4 has been completed. We'll move on to module 5. As early as possible, I will upload that. Thank you very much.